Complex fractions. It has a difficult sounding name, but I really don't think it is as bad as it sounds. So what is a complex fraction? It's really a fraction within a fraction. It's a fraction that has another fraction within it, or two other fractions. So it might look something like this. And there are a couple different ways we can approach these, but what it really means is it's this top fraction divided by this bottom fraction. And usually the way people find most useful is to do this, is to just rewrite it as the top fraction 2/3 divided by the bottom fraction 8/9, and then just proceed from there. In this case, we would, of course, change it to 2/3 times the reciprocal of 8/9, which is 9/8. We would multiply, we would look for things that cancel, and we would go from there. I would look at 9 as 3 times 3 so that I could cancel the 3 with the 3. And I would look at 8 as 2 times 4 so I could cancel the 2 and the 2. And then I would look at what's left, and that is just this 3 on top and this 4 on bottom. So everything after that initial complex fraction just proceeds the same as to what we've already been doing. So let's see what they look like when we make them a little more complex with polynomials and such. So your instruction will be to simplify. And it could look something like this. Let's go x plus 5 over x over x plus 5 over x to the 4th. And notice how the main fraction bar is a little bit longer, right? This fraction bar is a little bit longer than the other two. So you can see what the top part is and what the bottom part is. This whole thing is your numerator, and this whole thing down here is the denominator. So we're going to rewrite it. We're going to rewrite it as the numerator, x plus 5 over x, divided by the denominator, x plus 5 over x to the 4th. And then we change it to x plus 5 over x times x to the 4th over, that's a bad 4, x to the 4th over x plus 5. And then we multiply, but we also need to simplify along the way here too. So what I notice here is that I have got this entire binomial x plus 5 that matches on the top and the bottom. Because they're identical, we can cancel out the entire things and just replace them with ones, right? Those are going to cancel. The other thing I noticed is that I have an x and an x plus 4. I'm going to think about this x plus 4 as, I'm going to think about that as x, got some weird stuff going on with my drawing tablet, x times x to the 3rd, so that this x and this x can cancel. And notice all we have left here, 1 times x to the 3rd, and on the bottom, 1 times 1, which is just 1. And so we know then that we're done. That's it. It's just going to be x to the 3rd. All right, let's take a look at one more. One that's a little more complex looking, might require even a little bit of factoring. Okay, so let's simplify. And let's do this one. Y minus 6 over y over y squared minus 36 over y plus 4. I will let you pause this and try this on your own. See if you can simplify this complex fraction. I'll keep going here. So we know the next thing we have to do is rewrite it as y minus 6 over y divided by y squared minus 36 over y plus 4. From there, we'll change it to multiplication, y minus 6 over y times y plus 4 over y squared minus 36. And now we want to look to see if there's anything we can cancel. Now, what do we see? I notice we've got a few binomials here. We've got y minus 6, which is its own thing. We've got a y plus 4, right, which is its own binomial here. And then we've got this y, which is just a single term, so I'll leave that as it is. Then we have y squared minus 36. I don't see anything that cancels yet. So what we're going to have to do is take this thing and factor it. And one clue that we know we can factor it is it's a second degree binomial. Do you recognize what type this is? Hopefully you see that it's a difference of squares. And so we can factor it to y plus 6 times y minus 6. So this thing factors into this. Once we've done that, then we can hopefully see that this entire y minus 6 binomial cancels with this one, right? We can only, we can't cancel part of a binomial. It's all or nothing. Let's see what we have now. If we put it all back together and see if we're done, I see that our numerator is y plus 4. And in the denominator, we have a y times a y plus 6. So is anything able to cancel there? Are we able to cancel y and y? No, because we can't cancel part of a binomial. So that is it. That is what complex fractions are. They're really just a fancier division problem.